we are going to do continue matrices, but we are going on to inverses and determinants. And we are going to use our calculator in order to do these. I don't know if we'll get to determinants today. We'll probably just do inverses today, and tomorrow we'll finish up with determinants. We might touch on it a little bit today. Okay, so let's build the case for what an inverse is. So we're always reminded of what an inverse is supposed to do. So if I had like x plus 4 equals 9, and I'm solving that, I would subtract 4. So we'd say addition and subtraction are inverses because they undo each other. And if I had 4x equals 12, how do I solve that one? Divide by 4. Okay, so we would say multiplication and division are inverses. They undo each other. So what I want to be able to do, our goal is to find the inverse of a matrix. Because ultimately where we're headed with matrices is that we can represent a system of equations, a bunch of formulas with a matrix, and we want to be able to solve that matrix using an inverse. So we need to be able to get the inverse of a matrix first. So how do I know if I have the inverse of a matrix? Well, if I have a matrix A, and I multiply it by its inverse, and I'll signify that with a -1 right there, so that means inverse of the matrix, I want to get the identity matrix. Now that's not lowercase I, like as in imaginary number, it's identity matrix, and the identity matrix looks like this. 1, 0, 0, 1. Or, if it is a larger matrix, say a 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1, the bottom line is you get a diagonal set of 1s, and everything else is zeros. That's the identity matrix. So when I multiply two matrices and I get something like this, those are inverses. We of course do not want to waste time on matrices that we cannot find the inverse of. So like with so addition and subtraction with matrices, they had to be identically the same size. For multiplication, when I multiplied two matrices, I didn't have to have them be the identical size, but when I did my setup here, these inner numbers had to be the same, otherwise I couldn't multiply them, right? So I could multiply those matrices, they didn't have to be exactly the same size. So with inverses, I'm also not going to want to waste time trying to find an inverse if I can't do it. So a matrix is invertible, meaning I can find the inverse if it meets these conditions. First of all, it's a square matrix. It's a square matrix if it has the same number of rows and columns. So if it's not a square, then it is not going to be invertible. The second thing, if the determinant does not equal 0. Okay? Now we won't get to determinant right away here. We'll save that for the end of class. So we're going to go ahead and assume that if it's a square matrix for right now, that we can indeed invert it. So the two examples I'm going to do now, I am going to do by hand, and then for the rest of the class we'll work on our calculator and use our calculator to help us to do this correctly. Your calculator can actually give you the answer for an invertible matrix right away, but I'm going to be looking for the steps that get you there. So we're going to say our matrix that we start with, we're just going to make up one. We'll say 1, 4, 3, and 2. And I'm real quick, I'm going to take the determinant of that to verify. And yes, that is invertible. The determinant is not 0. So we can invert this. Well, the question is how. What we're going to do is we are going to augment our matrix. And that means divide it into 2 halves, with 1 half being the matrix I start with, and the other half being what I want it to become. And I want it to become this identity matrix. So that's my augmented matrix. And what I'm going to do is I'm going to do row operations to change the left to the identity matrix. So I want this side to become one, 0, 0, 1. And this right-hand side, that's going to be really, really ugly. Okay? But this right-hand side will be my answer. Okay? The left-hand side will not be my answer. My right-hand side will become my answer. So I'm just going to go on to the next slide so that I have room to do this, because I will need lots of room. So 1, 4, 3, 2. 1, 4, 3, 2. All right, here we go. 1, 4, 3, 2. Okay? Now, here are the things that I can do. I can add rows together. I can divide rows. And I could multiply rows and then add them to each other. So my goal is to get zeros. I want to get as many zeros on the left as possible by adding and subtracting. So it's going to take you a while to get the process down. But if you can remember the elimination method of solving when we're doing systems of equations, it's basically the same idea. So here's how we're going to write. This is going to look confusing at first, but eventually you'll get used to it, especially once you switch to the calculator and you can worry less about the little math details. I see that I can change that 4 to a 0. And here's how I'm going to do it. I'm going to do -2 times row 2. Now, I'm going to add that answer to row 1 and put that answer into row 1. So I'm going to replace row 1 with my answer. Here is what's happened. When I multiply row 2 by -2, I will get -6, -4, oops, that switched, -4, 0, and -4. Okay? Do you see what I'm talking about right there? I've multiplied this row right here by -2. You with me how I got this thing right here? Are you with me? Somewhat, maybe? And then if I add that to row 1, which is why I'm adding this, let's see.
Would it be -2 instead of...
Did I?
-6, -4, 0, negative...
Ah, yes. Good job. Thank you. -2 right there. Yes, good catch. That would have thrown that. See, a little error will make this really, really bad for us. All right, so now I'm going to add this row 2 to row 1. So what's -6 plus 1? You should say -5. Okay, what's -4 plus 4? 0. What's 0 plus 1? 1. What's -2 plus 0? What's -2 plus 0? What's -2 plus 0? It should be -2. You have to watch your signs. Your signs will throw you off. I didn't hear the name, that's why I said that. All right. Now, I actually, when I wrote this stuff down right here, I didn't say that I actually was going to change row 2 at all. I just was changing row 1. That's what this arrow thing means. I put my answer of all that stuff into row 1, which means row 2 has stayed exactly the same as it was before. It was row 1 that I was changing. So I have a 0. In general, now there's some exceptions. Sometimes you can't avoid it, but in general, avoid undoing zeros. We want zeros. We are not going to try to get any of the ones yet. We want to get the zeros first. All right. Now my goal, I want to keep my goal in mind. My goal in mind is I want the left-hand side to look like this, right? That's my goal. You with me? You with me what my goal is? Do you see a way that I could get this row to be that? Can I get this to be a 1 and then a 0? And hopefully you say yes, but if not, negative 1/5 times row 1. If I divide 5 by 5, I get 1, right? You with me? Okay, so negative 1/5 times row 1, and I'm going to put that answer to row 1. I'm going to go ahead and do that. The right-hand side, do not be worried if one side gets to be ugly and have lots of fractions. That's probably going to be the case. So negative 1/5 of negative 5 is 1. I have a 0. 0 divided 5 is 0. And on the right-hand side, I'm going to get negative 1/5 and then 2/5. And my row 2, I have not done anything to at all. But I'm about to. I want to get another 0 without undoing any zeros. And hopefully you see what I could do with these. I want to change that 3 to a 0. So I'm going to do negative 3 times row 1 and add it to row 2 and put my answer into row 2. That's going to give me 1, 0. Now, we are going to have to do a lot of little math right here, okay? Because we have fractions, don't we? Okay, so I'm going to erase this stuff over here so I have room. And I'll change my color. Oh. Okay. I hate that my thing, like, disappears so often. Okay, so I'm going to do negative 3 times row 1. That's going to give me negative 3. I have a 0. And then negative 3 times negative a fifth is 3/5. And then negative 3 times 2/5 is negative 6/5. Okay, that's what this row 1 is going to be becoming when I do this negative 3 times row 1. I'm going to add that to row 2. Row 2 is 3, 2, 0, 1. So when I add those, see, negative 3 plus 3 is 0, and 0 plus 2 is 2, and 3/5 times 0 is 3/5, and negative 6/5 plus 1, well, that's 5/5. That gives me negative 1/5. So that's what's going to go down into here. So I have 0, 2, 3/5, negative 1/5. And that's after I've done this operation right here. That's a row operation. I'm almost there. I need to get a 1 right here. So I'm going to do 1/2 of row 2 and put that answer into row 2. All right, so I'm not doing anything to row 1 at all. Is 2/5 and 0, 1. A half of 3/5 is 3/10. That's a 3. It's a horrible 3, but 3/10. And half of negative 1/5 is negative 1/10. All right, so actually now we are done. We have our answer. This is our answer right here. So our answer for this matrix, and I'll put it up here. Negative 1/5, 2/5, 3/10, negative 1/10. And we're going to follow this same process no matter how big our matrix is. All right. Let's see here. Okay, so this time I'm going to give you two matrices and we're going to decide if they are inverses. Now there are two ways to do this. One way is to take one matrix and find the inverse of it and see if it matches. That's probably the long way, and so I'm not going to bother doing it that way. So here are my two matrices that I'm given. I'm going to determine if these two matrices are actually inverses. So remember at the beginning of class I said, if two matrices, if I multiply them and I get the identity matrix, they are inverses. That's my goal. So I'm going to multiply these matrices and see what I get. So I'm going to take 5, 2, 7, 3, and I'm going to multiply it by 3, -2, -7, 5. I'm going to see what I can get when I multiply those. So let's multiply. This is a 2 by 2, and this is a 2 by 2. The inner are the same. My outer is 2s, so my answer is a 2 by 2. So I do row 1 times column 1. So we get 15 minus 14, or 15 minus -14, I should say. So that would be plus 14. Oh, no. I'm dumb. Minus 14. My bad. So I get a 1 right there. That should be a minus. It should be plus a -14. That's what I meant to say. The next one, row 1 times column 2. So that's going to be -10. Oops. -10 plus 10. So 0. The next one, row 2 times column 1, that should be 21 minus or plus -21. So that's 0. And then the last one, row 2 times column 2, is going to be -14 plus 15. So 1. And now that's not our answer. But is that the identity matrix? Yes. Therefore we confirm these are inverses. If when I multiply, I get the identity matrix, then those are inverses. All right, let's go ahead and do one more for our notes of finding inverses, and then we'll call that our practice, and then we're going to go to our calculator to see how it can help us. So I'm going to give us matrix B, and I'm going to say matrix B is 2, -1, 3, 5. And we're going to find the inverse. It is invertible, it's square, and its determinant is not 0, but we'll find about determinants tomorrow. So we're going to augment our matrix. So we're going to write down 2, -1, 3, 5. We'll augment it with 1, 0, 0, 1, like this. Now we're going to do row operations in order to find the inverse. Our goal is to get zeros. tell me one way to get 0. I need you guys paying close attention. I see half of you are asleep. You need to go to bed early. Okay, earlier. What you're doing is not working. Okay, how can I get some zeros here? By adding, subtracting, and multiplying the rows and combining them, I need to get zeros. How can I do that? The first one's the easy one. You don't want me to tell you that one and make you do the next one. Figure out the first one on your own.
I have 1. I have 1.
How do I add 1? I'm not allowed to do that. I can do times a row times something. I can take a row and add it to another row. And I can times a row and add it to a row. You have to think, when you're doing this, you have to think like elimination method from when we're solving equations. That's the only things you're allowed to do. So I can't just randomly add a 1. That's not going to work. Okay, I'll give it to you, but now you have to find the next one. The next one will be harder. I'm going to look at this, and I see, well, if I took 5 times row 1 and add it to row 2, what would I get right there? A 0, which is what I want. I want to get zeros. Okay? And I put my answer into row 2. Whatever you added to is where you put your answer. So we kind of missed what we were doing earlier. Perhaps we should do, okay, we'll come back to this. Let's do this. What if I had 2x plus 3y equals 8? And I'm going to solve that with x minus y equals 9. Solve that system. How do we do it? Using elimination method. Okay, I said elimination method. You're trying to do substitution.
Times it by 3.
Times what by 3?
The bottom.
The bottom one, right? So I multiply the bottom thing by 3. You with me? And then what did we do? But what did we do with those next? Add them. Now, I'm not going to finish this problem. Although we could, it actually works out pretty nice. I'm going to finish it. 7. Okay? Then what do we do with that 7? We put it back up here. I'm not going to finish that, I guess. But notice what we did. We times row 2. I times this by what? 3. Okay, so I times it by 3, and I added it to this row, right? And I got this answer. That is what you're doing over here. I'm taking row 1 and multiplying it by 5 and adding it to row 2. Pop your hand up if you understand what I just explained.
Well, why would you want a 0 and 5?
Okay, because my goal, remember the goal that we started with. I want to get this.
Yeah, but wouldn't that give you a 0 in the last part?
Yes, that's true, but we can deal with that later. To get this, I first get as many zeros as possible. I'm trying to get zeros. That's what I want. The order that I get them in is not going to matter. Alright, so we're going to go ahead and do that. So I have 2, negative 1. I'm going to leave that row the same as it was before. So now I have 2 times 5 is 10, plus the 3 is 13. Negative 1 times 5 is negative 5, plus the 5 is 0. 5 times 5 is 5, plus the 0 is 5. And 0 times 5 is 0, so plus the 1 is 1. And that's what I end up with. Now, sometimes it's helpful to take a little detour and go ahead and get a 1. So I'm going to do the next thing, and then you're going to figure out how to finish it out. I'm going to do 1/13 of row 2 and put that answer into row 2. And hopefully you see why I'm doing that is so that I get a 1 there and I have a much easier time on the left-hand side. So I get a 1, this will be a 0, This would be 5/13, and this would be 1/13. Yes, we're going to want our calculators here right quick. Okay, so we're going to find that inverse. We're going to continue. Now you finish it. How can I get another 0 from that matrix I have right there?
Multiply row 2 by negative
2 times row 2, and then what are you going to do with it?
2. Put it in row 1.
I'm not going to put it into row 1, I'm going to add it to row 1, right? I'm going to add it to row 1. And I put my answer into row 1. So whenever you add it, you put it in that row that you're adding it to. Alright, so I'm going to do some of this in my head here. 1 times negative 2 is negative 2, plus 2 is 0. And then I do have negative 1 right there. No problems. Now 5/13 times negative 2 is negative 10. So that's negative 10/13. I'm going to run out of space, so I'll write it again. Negative 10/13. Alright. And then, Nope. I forgot to add 1 to it. So this 1 is how many 13ths? That's 13/13. And I'm multiplying this by negative 2, so that's negative 10/13. So when I combine those, I get 3/13. So very important to keep track of that. Alright, and then the next one is going to add to 0. So I multiply that by negative 2, so that's negative 2/13. And I'm good. So we're almost done. There are 2 more things I'm going to need to do. Is this a 1? Nope, it's a negative 1. So I'm going to multiply row 1 by negative 1. So negative 1 times row 1 into row 1. Alright, that gets me almost there. So I have 0, 1, and then negative 3/13, 2/13, and then I have 1, 0, 5/13, and 1/13. Now, as Lila was suggesting earlier, well, wait a minute. That's not the right order, is it? I need, I'll just erase all this. I need that second row to be where row 1 is, don't I? So there is one more row operation we can do. We'll do row 1, exchange it with row 2. That's called swapping. We're going to swap the rows. It doesn't matter which order the rows are in, so we can swap them. So I'm going to put row 1 on top. And hopefully we didn't do a silly math error here. What was this? What was that? I can't read what I wrote there. What was that?
Negative 2/13.
Okay, but then we had multiplied it by a negative, right?
So it's 2/13.
So it's 2/13. Alright.
Yeah.
Alright, so what's our answer? This is our answer. So the inverse is the matrix 5/13, 1/13, negative 3/13, 2/13. Alright, and we will now practice this.